Today we're beginning our unit on trigonometry. So most of this is review for the people who took academic in grade 10. For the people who took applied in grade 10, some of it's review. There will be a couple new laws to learn as well that the academics have seen, but you guys haven't. So stay tuned for that. Quick review here, angles in a triangle have to add to 180 degrees. That means that like angle A here plus angle B plus angle C equals 180. That's an important thing to remember about triangles because we can use that to help us solve a triangle or find missing pieces of information in that triangle. Another thing that's really important to know with right angle triangles is to remember the Pythagorean theorem, which says the hypotenuse squared. So remember the hypotenuse is always across from your right angle here. So that's your hypotenuse. Your hypotenuse squared is equal to the sum of the lengths of the squares of the lengths of the other two sides. So I'm going to take my a squared and my side b and square it, add those together, and that would equal the hypotenuse squared. So then you, of course, square root that answer to get the length of the hypotenuse. In grade 10, we focused on solving triangles or working with triangles using these primary trig ratios. And remember, these only work for right angle triangles. So in this diagram, there should have been a right angle down here at C, which then, of course, makes this side the hypotenuse. And when we label that, if I have angle C in the bottom corner, then across from it is the hypotenuse, and we use the lowercase letter c to represent its side. If this is the known angle right here, or what I call the angle of reference, then what we have is this side here being opposite. And if angle A is my angle of reference, this is opposite side A. And then adjacent is the third one here, and that will be a little b. So it's adjacent or beside the known angle. So when you identify these sides in right triangles, always identify your hypotenuse first, because it will be the hypotenuse no matter which angle we're talking about. Your right angle will never be the known angle, well, it would be known, but it won't be your angle of reference. It will be one of the other two angles. So for our primary trig ratios, if we talk about the sine ratio for angle A, sine ratio is the opposite side. So in this case, it's little a over the hypotenuse, which is side C. Now, in terms of remembering this, we might use the acronym SOHCAHTOA. So comes from sine is opposite over hypotenuse. The cos is adjacent over hypotenuse, which is ca. Cos is adjacent over hypotenuse. And then tan is opposite over adjacent, so toa. So SOHCAHTOA. So that's an acronym that can help you remember this. I also have other things to help you remember if that doesn't work for you, but let me know if that's the case for you. All right, so we're going to remember how to use these primary trig ratios to help us find missing side lengths or angles. So example A here, solve for the indicated side length in each triangle. So this is side Y, that's the one I want to find. Here's my 90-degree angle. That makes this hypotenuse. So my first step is I identify which sides I have and which ones I know. So I have the hypotenuse. The 68 is my angle of reference. That makes Y opposite to the 68. So the trig ratio that uses opposite and hypotenuse is the sine. So sine is opposite over hypotenuse. So I'm going to just put the sine of angle A is opposite over hypotenuse, just to remind ourselves that that is what we are going to use here. And filling in what I know that angle of reference, so the sine of 68 degrees is equal to y over 15. So I'm filling in what I know. And to get y by itself, it's being divided by 15. So to undo the divide by 15, we're going to multiply both sides by 15. So I'm just putting that in brackets there. And you want to make sure your calculator is in degree mode. You either see a D on the display or the DEG for degree. If not, you need to find out how to change that. And if you just Google the brand of calculator you have, Google how to change it, you should be able to find that. Normally I would help you do that, but since we're from a distance, it's a little harder. But if you do have trouble with it, send me an email. If you can't find it on Google, let me know and I'll help you with that. All right, so depending on your calculator, my calculator, I actually have to put in the 68 degrees and then hit sine. Some of you will just do sine and then the 68 degrees. So I'm going to do that first, 68 and sine. I've got 0.9272 roughly, and then I'm going to hit times 15. I'm going to multiply that answer by 15, and I get about 13.9 on that. So my side y should be smaller than the hypotenuse, and 13.9 is. So I know my answer seems reasonable. All right, so 13.9 units. I didn't put units on these diagrams. All right, next example here. This side, across from the 90 degrees, is your hypotenuse. So I don't know my hypotenuse, nor do I care to know about it. Here's my angle of reference. That makes the 10 opposite to it. So I have opposite. That leaves M to be adjacent. So adjacent I need to find. So this is an look at the tan. This is a tan ratio question. Tan of angle A is opposite over adjacent. Look at the tan. And then I'm going to fill in what do we know. We know the angle A is 40 degrees. My opposite is 10, and my adjacent is M. Now, M is on the bottom. That makes it hard to solve. So, again, whatever's on the bottom, I'm going to multiply both sides by that to get it off of the bottom. That leaves me with M times the tan of 40 degrees equaling 10. Equals 10. Now, to get M by itself, it's being multiplied by the tan of 40 degrees. So I'm going to undo that by dividing both sides by the tan of 40 degrees. And then my M will be equal to, and I'm going to put this in my calculator. This is the way, again, depending on your calculator, I'm going to go 10, hit 10, divided by, so I've got my 10 here, divided by comes next. And then for me, I put in 40 and tan. Some of you will just do tan of 40 and it's fine. I have to do it backwards. I get 11.9 approximately here. Approximately 11.9 units. Okay, if you want to try the next one, go ahead and do that. Figure out what trig ratio to use, put the video on pause, and then check it out. All right, based on this, W is the hypotenuse. I need to solve for that. Based on this angle that's been given, this side is opposite, and this one's adjacent. Adjacent is the one that I know. So the trig ratio that uses H and A is cos. The cos of angle A is adjacent over hypotenuse. Fill in what we know. The cos of 20 degrees will equal 12.4. 12.4 over W. So again, we've got the variable on the bottom. Can't solve for it if it's on the bottom. Move it over by multiplying both sides by it. And then you're going to divide both sides by the cosine of 20 degrees to get that W by itself. Divide by the cosine of 20 degrees. And then that will give us what W equals. 12.4 divided by 20 cos equals 13.2 when I round that carefully. 13.2 units. Hypotenuse has to be longer than the other sides. That makes sense. It is going to be longer. It is longer. All right, word problem here. A 6.1 meter ladder leans against a wall. The angle formed by the ladder and the ground is 71 degrees. How far is the foot? The foot is at the bottom of the ladder from the wall. So with these questions, you want to draw a diagram. The diagram will be worth marks. I want to see that you, how you organize that information. So the wall I've drawn and the ground, and they run at a 90-degree angle to one another. My ladder's propped up against that wall, out like this. So this is my ladder. And that is going to be 6.1. That's supposed to say ladder there. 6.1 meters here. That's how long the ladder is. The angle formed by the ladder and the ground. So here's the ladder and the ground. That angle is 71 degrees in there. Okay, so how far is the foot of the ladder from the wall? So it's asking for this distance right here. Based on my diagram now, this is hypotenuse. Undo, there we go. Let's use a different color. This one is hypotenuse. So I have my hypotenuse. This is opposite. I don't care about the opposite. It's the adjacent I want. So adjacent and hypotenuse uses cos. So the cosine of my angle is adjacent. Oh goodness, adjacent over hypotenuse. There we go. So the cosine of 71 degrees is x over 6.1. Oh, this one's a little nicer. I'm going to multiply the 6.1 away from the x to undo it. And then I put that in my calculator. I'm going to get the cosine of 71 degrees and multiply that by 6.1. And I get 1.98. That's going to round to 2.0 if I go to 1 decimal place. So x equals approximately 2.0. So the foot of the ladder is about 2 meters from the base of the wall. So I finalized that with a therefore statement. So hopefully that makes sense. That's a review of how to use our trig from last year. There are some more examples on the next page, but I'll save that for the next video.